Okay, guys. Next we have Thevenin theorem. Like if we have Kirchhoff voltage law and Kirchhoff current law, then why we need another law which is Thevenin law. Thevenin's theorem. Like why Thevenin theorem is needed? The reason behind this is very simple. I will write it here that when no parameters in the circuit network is changing, then we can perform calculation by using Kirchhoff voltage law, which I will represent by KVL. K means Kirchhoff, V means voltage, and L means law, or Kirchhoff's current law, which I represent by KCL. Like if we have a circuit diagram, and in that circuit diagram there are many parameters, like we have resistors, we have voltage source, we have current source, and so many things. So if no parameters in the circuit if any parameter in the circuit does not change, then we can easily calculate the calculations, or we can easily calculate anything like output voltage or output current by using these two laws. But the things get complicated if one of the parameter gets changed. If any parameter keeps on changing, in the network or in the circuit, then by using KVL or KCL, again and again, makes our calculation quite lengthy. Even we can use both KCL and KVL, but for every change in the parameter we will use KCL. If the parameter change again, then we will use KCL again, and we will calculate the output voltage or output current. So we will use KCL again and again, so that makes our calculation much that makes our calculation more difficult and quite more lengthy. Now, Thevenin theorem provide an alternative to avoid the lengthy calculation in the network analysis. Now, to avoid this complexity, like the difficulty as well as the lengthy process by using KCL and KVL, Thevenin theorem, we can use Thevenin theorem, which can provide an alternative to avoid the lengthy calculation in the network analysis, and we can easily get the required results without a long lengthy calculation. So that's why we are using Thevenin theorem. Now I will plot a circuit diagram here. Suppose we have a voltage source, which is I represent by Vs. This is the voltage source. Here we have positive and negative terminal, and here we have resistors, and here we have load resistance, and suppose one resistor is connected here. This is, let's say, a resistor R1, this is R2, this is R3, and this is the load resistance, and this is the voltage source. Now it contains a voltage source, Vs, resistances R1, R2, and R3 in the circuit, and the load resistance RL. Now if the voltage source, let's suppose the voltage source and the resistance is like R1, R2, and R3. They are constant, they are not changing, they are fixed, their value are fixed, they are not changing in the process. Then we can, as well as this load resistance RL, it is also constant, then we can easily calculate the current through the load resistance or the voltage drop across the load resistance by using KCL or KVL, Kirchhoff current law or Kirchhoff voltage law. But if in case we have to calculate the load current, like we have to calculate the load current IL here for different values of load resistance, like load resistance is changing time to time, and we have to calculate this load current. If any parameter, let's suppose any parameter in this circuit diagram is keep in changing, then we cannot perform calculation by using the KCL or KVL, because we have to apply KCL and KVL again and again for every change in the parameter. That makes our calculation more complicated and lengthy. Thus we use another theorem which is called, I already mentioned above, which is called Thevenin theorem, which makes our calculation more easy. So this is the reason why we are using Thevenin theorem. So here I will first define the Thevenin theorem, and then I will consider one example and solve the circuit, solve the circuit by using Thevenin theorem. So first we will define Thevenin theorem. What is Thevenin theorem? Thevenin's theorem. It states that any two terminal linear network consisting of, like we have, this is a two terminal linear network, it consists of voltage source, comma, a current source, and resistances. These things can be replaced, this parameter can be replaced by equivalent circuit by equivalent circuit consisting of, that circuit will consist of single voltage source which is we represent by VTH, comma, connecting or connected in series with a resistance RTH. Now what are, like if we have a network, suppose this is a network which consists of a voltage source, might be there is a current source also. It consists of resistances like R1, R2 and R3. So this whole circuit can be replaced by an equivalent circuit which contain only two components. One is this voltage source and the other one is resistance RTH. What is VTH? Where VTH is the Thevenin voltage. Thevenin voltage, VTH is the Thevenin voltage, and it is the Thevenin voltage is the open circuit, and it is the open circuit voltage between the terminal. Between the terminals. I will explain it after defining this term also. And RTH is the equivalent resistance. It is called equivalent resistance or Thevenin resistance. Thevenin resistance, which can be calculated when all the independent sources like the current source, the voltage source, when all the independent sources are turned off. So here I will explain these two terms by plotting the block diagram. Now suppose we have a linear bilateral network. This is bilateral network. So suppose this is this network, like this network away from this point. This is this network. So this can be represented as, we have 2 points and here we have the load resistance RA. But remember that we have to use this sign. It represents a variable resistance because its value changes with time. So this represents variation in the voltage, and we have these two terminal A and B. Now the above circuit diagram, this diagram is basically represented by this one. So here we have these 2 points, this A and B are these 2 points. This is A This is B. Now here this part I represent by this block diagram. This is the linear bilateral network. It consists of voltage source, resistances. Here we have the load resistance, and the load resistance is variable resistance. Now this is equivalent to, this can be replaced by a very simple diagram. We have this point A and this is point B. This is the Thevenin voltage and this is the Thevenin resistance. So all the resistance are replaced by an equivalent resistance, which is called Thevenin resistance. But remember, to calculate the equivalent resistance, we have to turn off all the sources. Like if we have a voltage source, we have to turn off it. If we have a current source, then we have to turn off that current source also. And once we turn off, then we can calculate the Thevenin resistance. And the second thing is we have to calculate the Thevenin voltage. And the Thevenin voltage is basically the open circuit voltage. Like we have to remove this load resistance from here, and we have to calculate the voltage across these 2 points A and B. So that voltage will be called the Thevenin voltage. So this Thevenin voltage VTH is the Thevenin voltage. It is the open circuit voltage between terminal A and B. In this VTH, this Thevenin voltage is connected in series with this Thevenin resistance. So this is we call it Thevenin theorem. I will explain it by considering a very simple example in the next video. Thank you.